we go. Woo! It works. That's awesome. It's one of those rainy days outside where you don't want to be doing anything in the rain, but it's a perfect day to be tinkering in the shop. I have a unique project that really isn't like anything else that I've done on this channel. I'm going to give you a sneak peek of what's going on without revealing the whole project quite yet. So today's task is to take a bronze gear pump and build a support that will hold a DC electric motor in line with the pump so that we can run this pump off of a DC controller. And you're going to ask, why am I going with a DC motor? Why don't I go with a gasoline motor or a hydraulic motor or something else? And the reason is the DC motors were first readily available and quite cheap. So that's a bonus. The other thing is that these, because they are a brushed DC motor, controlling them with finite resolution, so from 0 to 1750 RPM, is actually quite easy. You just need to apply 0 to 90 volts, and that will scale appropriately for the RPM at the drive shaft. So it gives you a really easy way to control the speed of this motor and pump combination. So the goal for today is to take this piece of 3-inch channel and set up a couple of plates to mount the motor and mount the pump in line so that they will operate with very little misalignment. And to accommodate any misalignment that we may have occurring in this setup, I have these Lovejoy couplings here, so they get connected together with a little urethane spider that goes in between there. So we do have a little bit of room for wiggle to be able to get these lined up. It's not absolutely critical that these are perfectly aligned. So this will be a pretty easy project. It's really just a matter of making a mounting setup that will hold all of this in place. And then this setup will be used for the greater project later on. That will soon be revealed, but not right now. So the first thing that I did is went into my scrap bin and I found this piece of thin plate. It's going to be suitable for mounting the motor. It doesn't need to be super heavy duty because we're not going to be applying a ton of torque. And just the fact that we're going to be spreading out that contact point across 4 bolts, and the span from the edge of this channel to where the bolts are is going to be very minimal, and that'll basically be perfectly suitable for what we need to do. I've got our pump in place here, and as we can see, there is a mismatch in height or elevation between the two drive shafts. So I'm going to just use a caliper to measure what that distance is, and then come up with some type of, I don't know, a block or a piece of tube or something that we can set in there, maybe even another piece of channel. Lift that up and then get these two shafts aligned. I think this is going to be pretty easy to get set up here. I used the caliper to measure the differential between the two couplings when the pump was sitting on the piece of the channel, and it came out to 3/4 of an inch. Now I have a piece of this 1-inch channel here, and I think that's going to be the best bet because, as you can see when we come up top here, the two mounting holes are almost aligned over top of the channel. So by using this little channel to do the offset, they'll be actually accessible through the underside here, so we can sneak a bolt through to attach this into place. And really, as far as modifying this piece of channel here, we just need to take off a 1/4 inch. trimmed off 1/4 inch of that overall, that flange height in the bandsaw. So that is done, and you can see here our alignment is pretty spot on. Works out nice. So I've also got the plate for the motor mount. It is ready to go. So at this point, it's just going to be a matter of coming up with, it's just going to be a matter of getting everything lined up and tacked in place with the welder, finish welding it, and we should be all. So at this point, it's basically just a matter of getting the final alignment taken care of. We'll tack weld the mounting plates in place, and then it'll be a matter of just giving it a test, and I think we're going to be done with this. All right, we are ready to start getting this welded together. The motor's not in place yet. What I'm going to do is get the mount for the pump tack welded in place. Once that's fixed, then we can get the motor plate aligned, and then we can start to weld everything together. So today, rather than using the old MIG, I'm going to be using the TIG welder, and this is something new to my shop, and any opportunity I get to develop my skills with TIG welding, I think is well worthwhile, even if it takes a little bit longer. Just gaining that skill, I think, is an important thing, and the only way to do that is spending time and just doing it. Well, there it is. It's not good, but it's not bad. It's just a skill that you develop as you practice it. So whenever I get the opportunity to use the TIG welder, I will do so. And now this isn't my TIG welder. This is, I'm going to say, unofficially sponsored by a friend of mine. Howard lent this to me so that I can tinker with it. So I did not buy this. I'm not sponsored by Prime Weld, but first impressions are it's a good welder to learn on. I have never used a TIG welder beforehand, but as a first machine to use, I'm so far enjoying it quite a bit. So it's got the torch, and of course I am using the foot pedal, so it does pretty good. The neat thing is that you can get into a lot of tight places. It takes some body mechanics to understand how to approach that, but you're not shooting spatter everywhere, and it's a much cleaner welding process. So everything's welded up, everything's bolted in place now. So the pump basically remains fixed in location. There's no room for adjustment there, which is fine because the motor plate or the motor base has slotted mounting points on it so that we can actually kind of turn the motor from left to right. And what I did find is we were just slightly out of alignment, so I ended up tucking a little washer under each of those, or in each of these bolt holes here, just to move the motor up a tiny bit. So basically it's perfectly aligned now. That's exactly what we want. So I don't have the spider for this, but I don't think that's going to prevent us from finishing this up, getting some keyway cut and installed. All right, so what I've done is brought out my bench supply. It's a variable supply. It goes from 0 to 60 volts. It only does 5 amps, so it might not be quite enough for this motor, but the voltage should be fine. And just to run this with no like load, not pumping anything, I don't think it'll be a problem. So what we'll do is we've got it wired up already, so it's good to go. We'll just start dialing up the voltage here, and it should start to turn. So that's 10 volts, just starting to run. So it's a little bit noisy because of the gear pump. There is a little bit of slop in there. I had to rebuild the bushings on each side, but it works pretty good even with the rebuild. So that's the source of the noise. So we're going to get up to 25 volts. 40 volts. And we're right up to 60 volts there. That works well. I don't want to run it for too long without any water or any kind of liquid being moved through it. That is how these pumps are lubricated and how they are cooled. So yeah, to run it too long dry is not a good idea. So I think now that we've got this more or less set up, I'm going to find some plumbing pieces, and I'd like to try and move some water with this, and we'll see how well it does. I'm going to hook up one of these hoses here, like that. We've got our water filling up our bucket. That should probably be good. The other one here. And we are ready to begin. Let's get this going. It should be self-priming actually because of the gear pump itself. There we go. Woo! It works! That's awesome. So we're only running the motor at about 2/3 of its potential right now, and we're only running the supply at about 40% of its capacity. So far this is looking really good. Look at that. And this is the cool part, is with the DC motor, you can dial the voltage down and the flow. Because this is a positive displacement pump, the flow will scale proportionally to the voltage. So, when you get down to a really low voltage here, it's just going to move a tiny bit of water. Maybe a couple liters per minute. And you can dial this voltage right down, like even at 10 volts, it's still work. Well, that worked perfectly. I'm really happy how the whole build went together, and there's really not much left to do on it. Like I'd mentioned before, the one piece that I do need to get is the urethane spider that will go in between the two couplings. That will help reduce some of the noise transmission that's actually coming from the pump and stop it from making its way into the motor. It should quiet things up quite a bit, but aside from that, it's ready to go. So this is the first part of that secret build. I'm not revealing what we're building yet, but it will be something that I'm hoping to get out before winter time. So we're gonna be looking at a pretty steady pace for the next couple weeks of build videos. So be sure to keep your eyes open for what I have coming up next. And at some point you will get a full picture of the whole build and what we're gonna be doing. So thanks for watching. We'll see you soon. Bye for now.